Hello everybody. This is our second lecture under the polymers. We are dealing with unit 3A of our syllabus. So under this class we will be dealing with classification of polymers and the types of polymerization along with suitable examples. The polymers are classified based on the structure, based on the source, based on the monomeric units, based on the arrangement of monomers, based on the configuration, and finally on the based on the type of force. Now, regarding the structural basis of classification of polymers, we first come across the linear structure. So under this linear structure, you see that the monomeric units are joined to each other end to end to form a single chain. Now the green dots, they represent the monomers, and there is extensive van der Waals force or hydrogen bonding between the chains. The examples of polymers exhibiting the linear structure are the polyethylene, polyvinyl chloride, polystyrene, nylon, etc. Now, as the name suggests, in the branched polymers, the linear polymeric chain are attached to side chains. So that means there are small branches attached to the linear chain. Now, based on the depending upon the type of branching, the polymers can be high density or low density. Now, if the branching is minimum, the polymers are high density, and if the branching is extensive, the polymers will be having low density. Now, typical examples of branched polymers is the polyethylene molecule. Now, the third category is the cross-linked, in which the linear polymeric chain are joined to another polymeric chain, another linear polymeric chain via covalent bonds. Now, since the covalent bond is having higher force as compared to the van der Waals force or hydrogen bonding, so the cross-linked polymers will exhibit better mechanical properties as compared to linear or branched polymers. Now, in the case of network polymers, the monomer units, that is this green units represent the monomeric units. The monomeric units must have at least 3 functional groups, and they join to each other to form a network-like structure. And again, here the bonding between between the molecules are covalent bondings. Now, examples are epoxies and polyurethanes. Now, the second type of classification is based on the source. Now, if the polymers are present in the nature, that is either from plants or animals, we call them as natural polymers. Examples are cellulose, jute, silk, wool, leather, DNA, RNA, and natural rubber. Now, in the case of semi-synthetic polymers, if the polymers are undergo simple chemical treatment so as to improve their physical properties, we call them as semi-synthetic polymers. For example, acetate rayon, cuproammonium silk, viscous rayon, etc. Now, if the polymers are prepared in the laboratory by simple chemical methods, we call them as synthetic polymers. And the polymers that we see in our day-to-day lives is nylon, terylene, polyethylene, polystyrene, synthetic rubber, polyvinyl chloride, Teflon, Bakelite, etc. And these come under synthetic polymers. Now, the third type of classification is based on the monomeric units. Now, if the monomeric unit is only one type, so that means the polymers formed are homopolymers. Examples are polyethylene, and they are made up of only one repeating unit, that is the monomer is ethylene molecule. Other examples are polystyrene, polyvinyl chloride, etc. Now, the second category is the copolymers. Here the monomeric units are different. That means at least 2 different monomeric units joined together to form a copolymer. And the examples are Buna-S rubber, which is formed from 2 different monomeric units. One is 1,3-butadiene, another is the styrene molecule. Now, another type of classification is based on the arrangement of monomers in the copolymers. So, as I said in the previous slide, the copolymers are formed from combination of or addition of two different monomeric units. Now, based on how these monomeric units are arranged, we classify them on the basis of random copolymers, alternating copolymers, block copolymers, and graft copolymers. Now, let us look at this diagram. This diagram shows two different colors, each color representing a particular monomeric unit. So, in the case of the random copolymers, we find that the monomeric units are randomly arranged across the polymer chain. So, this is the random copolymer. In the case of alternating, the monomeric units are arranged in a alternating fashion across the polymer chain. Now, in the case of the block, this represents one block of the monomeric unit, and this represents another block of the monomeric unit. So, this represents the block copolymer. Now, in the case of a graft copolymer, the main polymer chain consists of only one type of monomeric unit, whereas the branches, they belong to a different monomeric unit. Now, let us come to the another classification which is based on the arrangement of the monomers. Now, the stereochemical arrangement of the side groups across the main polymer carbon chain, that is known as the tacticity. And there are three different classes under this, which is known as, first is the isotactic, second is the syndiotactic, and the third is the atactic. Now, under the isotactic, if the side groups are having the same configuration or the same arrangement across the polymer chain, we call them as isotactic. But if the side groups are arranged in an alternating fashion across the polymer carbon chain, we call them as syndiotactic. But if there is a haphazard arrangement of the side groups, then we call them as atactic polymers. Now, lastly, the classification is based on the type of force that holds the monomeric units. Now, the first classification is the elastomers, and here the polymer chains are held together by the weakest intermolecular force. Examples are Buna S, Buna N, neoprene. Now, fibers are having high tensile strength and high modulus of elasticity, and the polymer chains are held together by strong intermolecular forces like the hydrogen bonding. For example, the polyamides, the polyesters, etc. Now, the thermoplastics, the force of attraction is intermediate between the elastomers and fibers, and examples are polyethylene, polystyrene, polyvinyl chloride, etc. Now, the thermosets are having greater cross-linking, and they are heavily branched molecules, and they undergo extensive cross-linking, and they can again become infusible. That means these cannot be reused again and again. For example, urea formaldehyde resin, the bakelite, etc. Now, let us come to the polymerization process itself. So, there are two types of undergoing the polymerization reaction. One is the addition polymerization, second is the condensation polymerization. Now, as the name suggests, when the monomers, they go on adding to each other to form polymers, we call them as addition polymerization. So, here that means there is no elimination of any byproduct during the polymerization reaction. Another important criteria which is very essential for the addition polymerization to take place is the nature of the monomeric unit. The monomers, they must have at least one double bond or a triple bond for undergoing this type of addition polymerization. Now, let us come to the second category, that is the condensation polymerization. Now, here, as the name suggests, that there has to be an elimination of small molecules during the polymerization reaction. And another important criteria is the nature of the monomeric units. Now, in this case, the monomers, one monomer must have at least two functional groups, and two different monomers, they combine to give rise to condensation polymerization. So, what is the difference between addition polymerization and condensation polymerization? So, the first difference is that the monomer must have a double bond or a triple bond. Whereas in the case of a condensation polymerization, the monomers must have at least two functional groups, and two different monomer units, they combine to give rise to condensation polymerization. And the second difference is that under addition polymerization, no byproduct is formed, whereas under condensation polymerization, a byproduct like water, HCl, etc. are liberated. The third difference is that always the polymer formed under addition polymerization is a homopolymer, whereas the polymer formed under condensation polymerization is a heteropolymer. The polymer is a thermoplastic under addition polymerization, whereas the polymer under condensation polymerization, it may be a thermoplastic or it may be a thermoset. Now examples, let us come to the examples under addition polymerization. Ethylene molecule polymerizing to polyethylene, vinyl chloride polymerizing to PVC, styrene polymerizing to polystyrene. Whereas under condensation polymerization, the nylon 6,6 is formed from two different monomeric units like hexamethylene diamine and adipic acid, and nylon 6 is obtained from polymerization of caprolactam, and here polyethylene terephthalate is a condensation polymer which is formed from two different monomeric units like terephthalic acid and ethylene glycol. So this is a table which shows the common addition polymers. Now in this column, this is the name of the addition polymer. This is the formula of the addition polymer. This is the monomer that is responsible for the formation of the addition polymers. And these are the properties that are exhibited by the addition polymers and the uses or the applications of such addition polymers. Now let us take the example of polyvinyl chloride. The monomeric unit is the vinyl chloride, and this PVC is a strong rigid solid and it is used in pipes, sides and floors. Another example is the Teflon, which is polyethylene, polytetrafluoroethylene, and this monomeric unit is a tetrafluoroethylene, and this Teflon, it is a resistant smooth solid and it is used as non-stick surfaces or in electrical insulation. Now this table again shows common condensation polymers and their monomeric units. The first is the nylon 6,6. It is a polyamide. It is formed by the condensation of 1,6-diaminohexane and adipic acid, which is hexane dioic acid, and it is used in the preparation of ropes, fabrics and in the carpets. The second is the dacron, which is a polyester, and it is formed by condensation of terephthalic acid and ethylene glycol, and it is used in the preparation of clothes, films and tapes. Kevlar is a polyamide formed from terephthalic acid and 1,4-diaminobenzene, and it is used in the preparation of bulletproof vests. And here in the last row we have the polyurethane. It is formed from the polymerization of diisocyanato-benzene and ethylene glycol, and it is used in the preparation of foams. So this is the end of our lecture, and hope you have understood or you have had a clear understanding of the concepts of polymers that has been taught till date. And if you have got again doubts regarding this lecture or in the previous lecture, you may please raise your doubts or comments during our interactive classes that will be held shortly. And hope you have understood, and thank you for listening.